Have you ever looked up at the night sky, gazing at the endless stars scattered above, and felt a sense of wonder? Have you ever asked yourself what's really out there, beyond what our eyes can see, or our minds can easily imagine? For centuries, humanity believed the universe was like a giant, perfectly crafted clock, ticking away by Newton's rules, predictable, solid, and certain, every gear in its place. But as scientists peered closer, diving deep into the heart of atoms and the particles within, everything we thought we knew began to unravel. The universe at its tiniest scale isn't clockwork at all. It's wild, unpredictable, and full of mysteries that defy common sense. Welcome to the world of quantum physics, where reality itself seems to flicker and glitch, as if the rules are being rewritten in real time. Quantum rules are so strange and counterintuitive, they've led some to wonder, is our universe truly real? Or could it be a sophisticated simulation running on some cosmic computer? The Matrix explored this mind-bending idea, a world so perfectly simulated its inhabitants never suspect the truth behind their reality. But quantum physics raises similar questions, forcing us to confront the weirdness and uncertainty at the very heart of existence. So let's take a journey together, no complex math, just simple stories and curious questions, to explore the quantum world and its secrets. We'll discover how its rules sometimes feel like computer glitches, as if reality itself is running on unstable code. And we'll ask, does the strangeness of the very small suggest we're living in a cosmic simulation, or is reality simply stranger than we ever imagined? Are we, in some sense, inside a real-life matrix, where the boundaries between fact and fiction blur? The universe is full of secrets, waiting to be uncovered by those willing to look deeper. Let's open our minds, set aside our assumptions, and see what the cosmos has to tell us. The journey starts now. Get ready to question everything you thought you knew, and prepare to be amazed by the unexpected. Reality may be stranger than fiction, and the answers may surprise you. So let's peek behind the cosmic curtain together and see what wonders await. What is quantum physics? Let's start simple. Imagine a brick. It's solid, heavy, and seems unbreakable. But what if we could look inside, beyond what our eyes can see? Break it in half, then again and again. Eventually, you reach atoms. These are the tiny building blocks that make up everything around us, from bricks to stars. Classical physics works for bricks, but not for atoms. The rules that explain how a ball bounces or a car moves just don't apply at this tiny scale. At the atomic scale, we need new rules, quantum physics. This is a whole new way of understanding the universe, one that defies our everyday experience. Quantum physics describes the behavior of the tiniest building blocks, electrons, photons, and more. These are the particles that make up everything, yet they behave in ways that seem impossible. But these particles don't act like tiny bricks. They don't have clear edges or fixed positions. They're more like clouds of possibility than solid objects. Their locations and behaviors are fuzzy, always shifting. In the quantum world, things exist as probabilities, not certainties. It's a place where chance rules, and nothing is set in stone. It's a realm where particles don't have definite locations until you look for them. The act of observing changes what you find. Think of it like the difference between a sharp photograph and a shifting cloud. One is clear and certain, the other is always changing, never quite fixed. Your coffee cup seems solid because it's made of trillions of atoms. Their weirdness averages out. On the surface, everything appears normal and predictable, but underneath, the quantum fuzziness is always there. Every object hides a world of uncertainty and possibility. The foundation of everything is built on these strange, probabilistic rules. Even the most solid things are made from uncertainty. We don't see this weirdness in daily life, but it's always lurking beneath the surface. Our senses just aren't tuned to notice it. Quantum physics challenges our basic assumptions about reality. It forces us to rethink what we know about how the universe works. It tells us the universe is far stranger than it appears. The familiar world is just the tip of a much deeper, more mysterious iceberg. At its core, everything is uncertain until observed. Reality itself seems to depend on our act of looking. The world of the very small is a world of endless possibilities. It's a place where chance and unpredictability reign. And it's this world that might hold the key to understanding reality itself. The answers to our biggest questions could be hidden here. So, what happens when we look even closer? What new mysteries will we uncover as we peer deeper into the quantum realm? The answers get even weirder. The more we learn, the more reality seems to slip through our fingers. Welcome to the quantum realm. Here, the ordinary rules no longer apply, and the impossible becomes possible. Here, nothing is quite what it seems. Every observation opens up new questions and new wonders, and the rules are unlike anything you've ever known. Let's dive deeper and see just how strange things can get. One of quantum physics' strangest and most mind-bending ideas is superposition, a concept that challenges our everyday understanding of reality. Imagine flipping a coin, it's both heads and tails while spinning, existing in a blur of possibilities until it lands. In the quantum world, particles like electrons can be in multiple places at once, as if they're taking every possible path simultaneously. They exist as waves of probability, not fixed points, spreading out and overlapping like ripples on a pond. Only when we measure them do they choose a location, collapsing all those possibilities into a single outcome. Before that moment, they're spread out, everywhere they could possibly be, existing in a haze of uncertainty. It's not just about location. Particles can be in multiple states at once, like spinning both ways or being both on and off all at the same time. Measurement forces them to pick one reality, as if the universe is making a final decision when we look. This isn't a limitation of our tools or imagination, it's how the universe works at its most fundamental level. Quantum mechanics, the most successful and rigorously tested theory in science, says this is the true nature of reality. The universe keeps its options open until forced to decide, holding on to every possibility until the very last moment. Superposition is at the heart of quantum weirdness, making the world far stranger than we ever imagined. It's a world where multiple realities exist, side by side, until we look and force a single outcome. And when we do, the universe makes a choice, collapsing all those possibilities into one reality. Reality, it seems, is undecided until observed, waiting for us to peek before revealing its secrets. That's the magic and the enduring mystery of superposition, a phenomenon that continues to baffle and inspire. The quantum world is stranger than fiction, and its secrets are only just beginning to be revealed. Here's where things get even stranger: the observer effect. In quantum physics, just looking at something changes it. To find an electron, you have to interact with it, like bouncing a photon off it. But that changes the electron's reality. The most famous example is the double-slit experiment. If you don't watch, particles act like waves going through both slits at once. But if you watch, they act like particles, choosing one path. The act of observation changes the outcome. It's as if the universe knows when it's being watched. Reality snaps into place only when we look. When unobserved, it's a world of possibilities. When observed, it becomes definite. This is one of quantum physics' greatest mysteries. Why does the universe care if we're watching? The observer effect blurs the line between reality and perception. In the quantum world, watching truly changes everything. Let's shift gears to The Matrix, a world built from computer code. In the film, reality is a simulation so perfect, no one suspects the truth. The rules, like gravity, are just lines of code. Sometimes the code glitches, déjà vu, repeating events, cracks in reality. For most, these glitches go unnoticed. For a few, they're clues. The Matrix suggests a reality so well simulated, its inhabitants can't tell it's fake. Only by spotting the glitches do they glimpse the truth. The idea, a world built on information with rules and potential glitches, isn't just science fiction, it echoes the strangeness of quantum physics. What if our universe is built on code too? What if the glitches of quantum mechanics are clues? The line between science fiction and science is thinner than we think. Now let's connect quantum physics and the Matrix. In video games, only what you see is rendered in detail, the rest is just potential. This saves processing power. Quantum physics seems to work the same way. Particles don't have definite properties until observed. The universe renders reality on demand. This is the simulation hypothesis. Maybe our universe is a program, calculating only what's needed. The observer effect isn't a mystery, it's a shortcut. Dig deep enough, and everything is information. Numbers, equations, code. Physics becomes a process of reverse engineering the universe's source code. Are we discovering the rules or the programming? The idea is provocative. Maybe reality is information at its core. The simulation hypothesis blurs the line between science and philosophy. Could we be living in a cosmic program? If we're in a simulation, we might expect glitches, just like déjà vu in The Matrix. Quantum mechanics offers some candidates. Quantum tunneling particles pass through barriers they shouldn't, as if the code allows improbable shortcuts. Quantum entanglement. Two particles act as one, no matter the distance, like linked data in a program. Einstein called it spooky action at a distance. In a simulation, their connection is built into the code, no signal needed. And then there's the pixelated nature of reality. The Planck length is the smallest possible unit. Space and time are grainy, not smooth. Why would reality have a resolution? Maybe it's a feature of a simulation. A digital universe would need a finite grid, pixels of space and time. These quantum glitches might be the seams in our cosmic code. Are they clues to a deeper truth? The evidence is strange, but the mystery remains. So, does all this prove we live in the Matrix? Not at all. These ideas are fascinating, but they're not scientific proof. The simulation hypothesis is fun to ponder but impossible to test. We can't step outside our universe to check for code. Anything we observe could just be another rule of the simulation. Our sense of weirdness comes from our limited perspective. Quantum mechanics may simply be how the universe works. The computer metaphor is just that, a metaphor. Most physicists see quantum mechanics as the best description of reality, not a glitchy program. The weirdness is a feature, not a bug. The parallels are intriguing but not evidence. Science focuses on what we can test and predict. The rest is up to our imagination. So where does this leave us? At the edge of a great mystery, quantum physics has revealed a universe stranger than we ever imagined. It forces us to question reality, observation, and existence itself. Whether or not we live in a simulation, the questions quantum physics raises are profound. Why does observation collapse possibilities into reality? What counts as an observer? We don't have all the answers. The quest to unite quantum mechanics and relativity, the very small and the very large, continues. Maybe the universe isn't a clock or a computer, but something entirely new. We're just beginning to explore its secrets. The search for understanding is what makes us human. There are many more mysteries to uncover. The universe doesn't give up its secrets easily. Our cosmic journey has only just begun.